Okay, so let's now do the thing that I wanted to do, just while we're at the timer. Use key pressed, VK, key event, VK up. So we'll do camera X plus. We really should be storing everything as floats as well, but oh well. Okay, so so output will be minus, right? Actually, no, plus. That'll be minus. And that's because I should have done subtract instead of add. Right, left. Let's see what happens here. Yeah, I'd expect that to happen. Alright, cool. So, good. So far, so good. Now I kind of want to add static objects everywhere, just because. So fill rect, for example, x minus equals x offset, y minus equals y offset. The reason I'm doing this is because we want to. So let's just do like private vector 2f rects. It's a new vector 2f. Just make it a list. So I'm actually not going to model the gameplay now. About 100 of them, or 200 of them. So we'll do like 20 y times 50, and then like 900 as well, or something. Screen dot fill rectangle rect dot x rect dot y. We'll go with like 32. Or something like a blue color. Okay. Can't see the other one for some reason. What did I do? Oh yeah, whoops. I meant to do like 480 because I forgot that. Okay, there we go. So, the reason I put this here is so that when we move the camera, we can actually see what's going on. So see if I move the camera up, I can actually see that the camera's moving. And I just realized I made it go down, so up. Lol cakes. Easy fix though. We'll just do -y. Why is this moving at a different rate? What do I do? Well, that makes no sense. What? Oh, because it's the rectangles being filled. I see. So this should actually be using the original ones. Oh. Okay. So now so we got a little camera situation going on now with no clipping yet. And very few mouse things. Now we can actually make this thing grow. So, camera. We'll leave that in there, but we'll just say camera Y ++, just in general. Let's see how quick that goes. Minus is what I meant. I really should reverse everything though, shouldn't I? Because it's gonna get annoying. Okay, that's too fast. Oops. So we'll start off with like 2 or something. Alright, and I probably want to set the camera to be like -500 or something to begin with. Or just even like 1000. Well, basically 960. Okay, cool. So. Oh, jeez. I'm looking at the chat right now. It's great. Yes, the source code will be out. Oops. What did I do there? Undo typing, right, okay. Keyboard I'm using is a Dust Keyboard 4 with, it's Dust Keyboard 4 Ultimate with brown switches. Okay, so where did I stop? Yeah, so I've got scrolling map and stuff, good. Okay, so now we just have to control the curve. So we got the points. All right. So if we just grab points like 2, for example, set it equals camera Y -50. All right. So let's just set the X to just generally be, this is where I need all my stuff again. My debug stuff. Okay, so this is point 1, this is point 2, point 3, point 4. Point 1 and 2 will always be at the bottom. So point 1 we can set to be like right there. Should probably just print this out. So like 284 or so. 284 or so, and then like at the bottom. So yeah, I just need the x offset really. So yeah, like 200, like yeah, screen divided by 2. Anyway, this one I guess we can probably set it up to be a bit lower and a bit higher, like that. So far, point 0 is going to be like 280, comma, we'll set it to like 500 for now. 1 will be maybe like 230, and then what was that? It's about 100 less, so 400. And 3 and 4. So 3 is, oops. 3 is that one. So 3 I want to be on the right side, I guess. So 3 will be something like, oh yeah, 380, and then 224. And we'll just set this up to be like camera.y or something. Okay, cool. So let's undo that. Change this back to -1000. Last time I sharpened a pencil was probably in like primary school or something. I don't know. I don't really use pencils that often. Pens all the way. So there's the answer to your question. GM Skittles. Okay. Points 0 equals new vector 2f. 280, 500. 230, 400. Camera.y. Camera.y minus 50. 224. 380. Let's just see what this looks like. We're really going to see the gaps now, because it's obviously stretching. But we don't need to stretch because I'm actually going to also bring this stuff up. Okay, so let's start with this. So I'm guessing we probably want it to be let's see, 900-ish. I kind of do want to take it out a bit though. We ran out of blocks. Good. Let's restart that. No, like 30 or something. Not 30, maybe like 80. That actually doesn't look too bad for what I'm going for. Although, yeah. Okay, this stuff, let's make it, we need to make way more of these as well. 100, let's make like 10,000. All right. So, pull this down maybe. Okay, so let's actually pull these down quite a bit. So like 500 or so. We need to have a time variable so we can do animation. So let's make 3 do some cool stuff. So we'll start off with math.sine time divided by like 120 float. Okay, plus like 250. That is just way too. Okay. Let's just dilate that. Okay, that's way too slow. It's pretty cool. Oh, what aren't I making? Yeah, it's gonna be a bit of a growing plant situation. It's gonna be a scrolling up game. You have to use the left and right arrow keys. Right now they just move the camera, but to control the chaos and kind of stay in the middle, because if you hit the edges you die. Okay, I should probably add some randomization to these things. So this could be pretty easy to do actually, which is what I like about the game. We could easily do kind of per pixel collision as well with all these. So might be a bit slow. We actually seem to be running very fast though. Let me not print the mouse out. Like 600 FPS for this, because this is so unoptimized right now. Is actually good. So favorite toast spread. I like, it's either Vegemite, so butter and Vegemite, or butter and honey. One of those two. I also like peanut butter though, so lols. Alright, I want to animate the bottom 2 points as well. Yeah, we could probably just animate X, leave Y alone. That's pretty cool, I think. We need it to animate at different rates though. This one's pretty cool. It's just all crazy flying around. Okay, so let's keep the first part of this, which is 0.1 maybe? No. 2? No. 3. Okay, let's keep 3 from moving really. Also, 2 is pretty insane. Plus 50 needs to be like plus 200 or something, so it stays within the bounds. 250. Yeah, times 200 might be a bit too much. Also, I don't like him moving up that much, so maybe move it down a bit. Cool. Okay, so yeah, this is a bit annoying, isn't it? Is that 0.1? Yeah. Yeah, 0.1 should probably go across the whole screen. But like, okay, so really we want it to be times 250 plus 250-ish. That's much better. Maybe just make it 200 plus 270, so it centers. Okay, that's good. And I guess we could add some key input to the first point, so that's 0.3. So excuse me. Okay, so I can control this point now, which is pretty cool. No, didn't want to do that. Okay, so to do, we need to make this line a lot thicker, which is probably not as simple as it sounds. And B, or 2, we need to figure out some kind of gameplay. So if this moves us left or something, okay, let's stop the debug rendering. Wow. Okay. Not what I wanted. This should be like 500 or something, I think. Or not. Minus 500. Yeah. Okay. Okay. Yeah, quick nap. Okay. So what do we need to do? Yes, we need the concept of forces. That's one thing we need. And then, yeah, so let's just stop the debug rendering, because it is actually kind of interfering with everything. See, that looks much different. Texting while programming kills 1,000 people a day. Nice. The time in Australia, if you look in the bottom right corner, is 11:40 a.m. I just woke up a couple hours ago. So yeah, okay. So maybe let's make this green. So in selected is going to become color. Don't really care about this. Color is going to go here, and one level draws this. Color we're going to choose is going to be something along the lines of green. So maybe like 20 a 40 or something. I don't know. That's actually a very nice green. I like that green. All right, so Y. Yeah, let's make it a lot wider. So we've got to think about how we're going to do that. Because that's probably not the easiest task. Let's take a look at how we actually draw the line again. I mean, like, to be honest, we could be all dirty and hack it and just say that when we draw the pixel, let's actually draw like 4. I'm not sure if I want to do it that way though. We need to remember to do our bounds checking though. Okay, just for now, because I don't think this will work very well. Oh wow, yeah. That's not really ideal at all. Yeah, I mean, we could do that. Actually seems to work pretty well. Okay, let's do that. So what we can do then is just say that we'll just fill a rectangle. XY with height, color. See what that looks like. Wow. It's yeah. It's amazing. It's because of the offset stuff. Lol. Why am I not seeing anything? What? What? That does not make any sense. Why are you lolling me? That's the question. What are these values? What? Are they off the screen? Oh, they would be. Oh, I see. There we go. That actually looks a lot better than I thought it would. Wow. That's, yeah, it's something. Look, I can live with that. Like, obviously the end is bad, but everything else actually looks pretty decent, to be honest. And especially because it's actually not going to be that thick anyway. And we can actually set the thickness based on what the y is. So int thickness equals, we might do something like y minus 500 divided by like 12. May have been too low. Maybe negative. In fact, it probably is negative. Yep. Why is that negative? Why is that negative? Oh, just because it's already... No. What? Ah. Okay. Well, yeah, that makes sense. So let's just do something like... Except maybe like more. And like a lot more. Yeah. Something like that might work pretty well. It's like a snake. That looks nice. Rendering circles is a lot harder than rendering rectangles though. So like as in it's gonna form worse. And yes, it is a plant. Well done. 100 points. Okay. Yeah, it looks like a tentacle, doesn't it? Look, it works very well, to be honest. I'm very happy with this. Okay, maybe let's set the clear color to something better. Where's colorpicker.com when you need it? So what's a nice kind of bluish? We could do like a gradient. That's pretty good though. Let's just steal that. I take that back, that's not good at all. Does not work with green, confirmed. Yeah, maybe we'll do something like dark. Yeah, I don't really want to do that though. We could always draw an outline on this plant. In fact, that would be cool if we did like toon shading. We could totally do that. We could probably even write like a toon shading, like a toon shader for this if we really wanted to. That looks a lot better. Maybe we can even spice up the blue. It's a bit too much. Hey, it was good. Maybe like... Okay, that's nice. Like a gradient would be nice, so we might do a gradient or something. Okay, so before we actually start with real graphics and whatnot, I do want to say, one thing I should mention is because we're drawing not pixels anymore and we're drawing rectangles, we can probably reduce the segment count a little bit, not like 100, but like a little bit. See? And that would do very little. So it's a good, like, not that we have to worry about performance yet, but, and not to mention I could probably double this performance pretty easily by optimizing a lot of the code that I wrote. But yeah, we don't have to do that now. All right, let's bring back our debug rendering. So let's also get rid of this. Okay, and let's start thinking about forces. So the whole concept of the game, let's actually make the gameplay now. Hopefully I'll have the base gameplay done in about an hour. So we can start polishing it and then maybe just start actually texturing it and whatnot. So, yes. So my idea is, as your vine thing is growing, right now it's actually, one thing that I did is actually the whole thing is moving rather than actually leaving a trail. I'm not sure which would be better, to be honest. Like, should that just stay where it is? Because I don't feel like we probably didn't even need a Bezier curve if we did that. No, that's probably more fun. Anyway, at the tip, which is what you are, there needs to be something that blows you left or right. Because that's kind of going to be the concept of the game, right? Because you want to avoid like these walls, And you need like, we need like some kind of forces really that, or maybe even obstacles to avoid, where we just don't want to hit them. And maybe if the rest of our tail hits them, they just like shatter or something. But as long as the head doesn't hit them, we're good. So, yeah, something that just kind of pushes us left or right. I just don't know. No, we're not trying to fertilize an egg. Yeah, that's not a bad idea. So maybe if there were like, since it is a plant, maybe if there were like spots of sunlight, if you stay in the sunlight, you grow faster. Whereas if you are not in the sunlight, you grow slower. That's actually a nice idea. The reason I like that idea is because it also gives us an excuse to do some kind of cool lighting effects, which would make the graphics look better. So yeah, we could do something like that. Yeah, and maybe there are like clouds or something just in the background. Just don't really care. We could put a lot of detail into this, obviously. But the basic idea is, yeah, still here. Raindrops as well could be nice. Cool. Lots of ideas. It's only like midday. So much time. This game really came together quickly. It's good. Okay. So let's start with the initial thing, which was providing some kind of force that just comes every now and then. So I'm just going to play this by ear, kind of, and just make it really basic to start off with. So what will happen is we'll have a random, so we could make it, I don't really want to make it predictable, that's kind of the point. So random dot next int, so we'll say we will generate force maybe like 10 minus 5, right? So this should give us a value here that is roughly between -5 and 5, or -4 and 5, right? In that case, I might actually just do that. No, we're getting 6s. 6. Okay, cool. That's what I meant. And then we could say we don't want to generate it every frame. We just want to say that so what's time? We could do this based on time, we could do this based on y. We can do this based on time, I think. So if time mod 200 equals 0, it's time to generate a new force. And points3.x will probably just be like plus equals force. Now this might be very difficult to control though, that's the thing. So far it's fine. Well, taking me that way. Oof. Whoa. Yeah, see that's the issue. I can't even move sometimes. Let's take off the debug rendering because that's just making me sad. Okay, so this is already kind of, it's not really difficult, but I think it should change more often though. It should change at random intervals as well, but a bit more often. So maybe like random.nextInt 100 plus 100. Oh, see, I just died there. Pretty fun. Just 2 buttons as well. All right, shall we do obstacles? Okay, so I think the movement should be less static as if it gains momentum. Yeah, we could definitely spend a lot of time tweaking the movement. What I will say though is that kind of do want to do the art for it. Let's add obstacles there. So this code is kind of a mess right now. We'll just do like wall. Public wall I'm not actually tired, I just got up. I'm just dedicated. Oof. Oh man, that's so difficult. Because it might change at any moment. I imagine this would get quite frustrating. So if your tentacle hits there, I think the walls will just smash themselves. Because why not? Tentacle, I called it a tentacle. I meant plant. Lols. See, I'd be dead in this case. I can't actually move even. Whoa. Now I believe we could increase the speed at any time. And like we'd still be okay. So, because camera Y speed is 3, like if I set it to 8, yeah, everything would still work well. Oh, actually no, the plant did not work well. So camera speed equals 3 or something. Okay. So now it does. Okay. So, let's perhaps do Okay. Show. Let's do, I guess, destructible walls. Let's just make some textures, I think. So how big 64 by 64 should be, like walls or something? kind of want to just make it. Be cool if it would move down as well. Okay, let's do that. So we'll start off with a circle. Can I just do a radial gradient? That would be easy. No, don't just get rid of my thing. What are you doing? Why would it do that? What? Why does it get rid of everything? I guess it draws it on top. So let's maybe make this completely transparent. There we go, that's better. So let's undo the fill. Except let's do it the other way around. Well. I do want to do it the other way around. Let's just say this is the middle. That's the outside edge. We'll flip this. And then I guess we'll just keep that. How do I invert selection? Alright, so there's our stone thing. I need to add some detail and whatnot to it. Probably just add some cracks and whatnot. All right, cool. Add a few imperfections. And then let's just like blur the whole thing. Not that much though. Don't know if that's actually helping. Distort. Bulge. Could have some noise. That may make it look better. In fact, yeah, I like that. What do you think? Looks like a little planet. It's because it's perfectly smooth. We need to not make it perfectly smooth. Let me undo the noise and do this first. All right. Yeah, that did kind of ruin the lighting. All right, look, that's gonna have to do for now. Yeah, I'll add one of these things. Maybe not. Lols. If only I could art. Okay, so where am I saving this? All right. So. So, for int y equals 0 less than we're just copying the pixels, that's it. So this will be xx plus yy times texture.get. Okay, so we can draw textures now, good. So let's maybe replace wall with a private static texture equals new texture. Res rock.png, and then let's just draw texture. Texture. What? Well, firstly, I don't know why we're... Oh, I see. And that's probably not the... Oh, it is. Okay. Yeah. So we should see rocks now. We should have seen one by now. Odd. Very odd. That's interesting. Why is that? It's weird. Ah, I don't know why. Cool. So, unfortunately, we're dealing with 24-bit colors, so let's just encode pink to be transparent. Let's save that as a 24-bit image. Okay, so now we can just say that's color. And if color doesn't equal pink, then we'll do that. Except that like massively did not work. It's still storing it. I mean, I guess it would be. We didn't even have to do that, to be honest. We didn't even have to do that. In fact, let's not do that. Let's just be a man and save it as a 32-bit image. And then we'll just say that if color and that is greater than 0, we'll draw it. Oh, whoa. Lol. Why? Oh, because it's, yeah. Right. Because Java doesn't have unsigned integers, that's why. Really? What's wrong with that? What? The answer is nothing is wrong with that. It must be because of Java's junk. We'll probably have to do it the other way around, maybe. In fact, what does this give us? Oh, this is not fun. It still doesn't make any sense. see what this does. Nothing. Okay. Why not? I still don't understand what the issue is. I think it's just because this is just not correct in Java. Just wait for that to happen. Or not. Yeah, it's bloody negative. 1, 2, 3, 4. Yeah. Fudge. That's really annoying. I guess we could just say if it's less than 0 or something. There we go. Okay, cool. So we can do that. Bit of a hack. So, this is just because of Java's lack of unsigned types, which is actually just terrible. Whoa, let's not fall over. Okay. 12:30, eh? Ugh, I lost that. Okay, so for now, let's just get them to disappear, I guess. We made them explode or something. But for now, let's just say that when we're drawing this, it's gonna be pretty expensive actually. But So let's do something like... Oh, I'm getting tired. I haven't had coffee. Yeah, collision stuff, that's right. Oh yeah, I got sad because it was so expensive. What's a good way to do this? This is in the render function as well. It's really annoying. Okay. So, enough break. Let's do something different. Let's give draw curve access to level. Now let's say for in I equals, or in fact for wall level dot walls. Lols. So let's just say that wall dot collision new rectangle xy thickness then wall dot remove or wall dot destroy. Okay, and so now in level, we'll have to just go through every wall here. Is destroyed. We'll simply say walls dot remove I. Minus. All right, so let's see if this works. No, I'm not still selling bikes, and I know that you saw that. That's what I was lolling out earlier. I really should probably take that down. All right, cool. So this seems to work. Bikes. It's pretty funny. That's like 3 years old, probably. Well, okay, so if you hit it with the head, you will die. If you don't hit it with the head, it will just destroy the thing. Pretty simple. So we should probably do like an explosion. Oh, I just closed chat. Why did I do that? Oh, worst.com. All right. The head is being moved. Performance is actually pretty good, better than I expected. Okay, so now we need to just, you know, get started. Okay. Let's... Yeah, so we should probably make some kind of explosion animation. So let's do that, I guess. After Effects time. So where's that thing? We're just gonna slice this up, that's all. Into like fragments. So, let's just... Okay. So maybe like one. Let me just... Is there an easy way to do that? I'll just expand the masks later. Alright, so 12 pieces. Let's just expand them a little bit. 1 pixel. I guess we'll animate. Yeah, okay, so we will probably do this for the sake of being easy. Each one of these images will be exported to a sprite sheet, and it will have an animation of it rotating, so that I don't have to bother doing rotation code. But the actual position will be done in code, so we can randomize it a bit. So let's make a sprite sheet, I guess. So each piece, how big is each piece? I mean, they're all different sizes though. That's kind of the issue. We could probably make a sprite sheet for each piece though. So like, grid wise. Copy this in. I guess we'll start with the first mask. Way too small. So we want a sprite sheet. For each of these pieces, probably. So we'll generate a grid. Let's make a new layer for that. So we'll probably just have 3 frames of animation. Generate grid. Border 1. How do I? Oh well. So what are the sizes? Oh, I see. 32 by 32. Anchor 0, 0. Composition 96. Actually, instead of doing that, I could probably just make it wide. Might be better. And let's make these black. Okay, so we've got this situation now. So let's have that here. Let's duplicate it, rotate it, and duplicate it again, rotate it again. Looks a bit like a pizza. Ah, I wish I could bash all this. I don't use Eclipse that much to warrant like a dark theme. In Visual Studio I use the dark theme because I use Visual Studio a lot more than Eclipse. I'm just looking at the chat for a bit. I enjoy working at EA. If I didn't enjoy it, I wouldn't work at EA. It's pretty simple. But one of the reasons I enjoy it so much probably because I work on the engine team. And obviously making game engines is what I do. It's my favorite part of programming. In fact, my favorite part of programming is probably like graphics programming, to be honest. But engine programming in general is just what I like doing. It's fun. I like, you know, diving into the low-level stuff and optimizing and doing all that stuff. It's fun. All right, let's save this. Yeah, we'll save it in the same folder. Yeah, I am one of the youngest people that work there. Did you know anything about game engine programming before I started there? Well, yeah. I mean, like, you know, the entire game programming series is, you know, how to basically make a full graphical engine and everything from scratch. And one of the reasons I actually did get a job there is because my boss, who interviewed me, said that he actually watched my videos, like, because I put them on my resume, and he enjoyed them. So there you go. No, I can talk about the stuff I work on. I don't think people mind too much. I probably can't talk about upcoming projects, but ones that are out right now, it's probably fun. Anyway, now's probably not the place though, since I do have to finish this game. But yeah. How did I learn coding and how did I get so good? Well, just really just by being passionate about it and just being determined to actually learn. Because if you're really passionate about something and you really want to learn, then you just have to, you know, just put your head down and start learning it. There's no real way to do it. Just keep working on projects and keep doing stuff. What languages do you use at EA? Oh, what languages don't I use? Primarily C++ and C#. Those two are the common ones. As an engine programmer, because C++ for the runtime, C# for all the tools. What is my favorite language? My favorite language is C++, because I just think it's so important to like, if you're writing anything that's performance critical, C++ is just, I mean, there are some annoying things with it, but I just really like C++ though. That's the thing. I just really like it. You know, it gives you all this direct memory access and all the low-level stuff, whilst also being high-level enough that you can abstract things very well and do you know, like fairly fast development and whatnot in like an object-oriented kind of way as well. But it still gives you that low-level stuff when you need it. You know, such as intrinsics and whatnot, and SSE and SIMD, as people are talking about in the chat, but also stuff like inline assembly and being able to obviously, you know, once you compile something, being able to disassemble it and actually see the assembly instructions and then be like, okay, I need to optimize this because this is going on and this is bad and all that stuff. So, and people saying that C++ isn't safe, like, you just bad programmers. Like, come on, like, just write code that actually works and you won't have a problem with C++, honestly. I don't know why everyone hates on C++. And this whole notion of, like, smart pointers as well is literally for people who just cannot write code. Like, manage your memory correctly, and you will never have a problem with it. Anyway. Yes, we do use C++ 11. We compile most of our things with C++ 11. We don't use C. Like, obviously there are some things that use C, like external libraries, for example. But I don't think we have any C code. I don't think so. I'm not sure. I haven't read every single source file. There's like 8,000 of them. So, yeah. But yeah, especially if you're like, the only part of smart pointers I would accept, and this isn't this isn't really a smart pointer, but like reference counting, for example, that is something that is generally extremely low overhead, and it's just, you know, generally a good idea to do if you're working in a large kind of, especially a large game, which obviously keeps allocating and has to keep track of references and all that stuff. So ref counting is good in some scenarios. But smart pointers, I don't think we've got any smart pointers at all. I don't think I've ever seen one. Which is good. So yeah. Especially if you're doing something that's performance critical and you've got a team of good engineers on it, then smart pointers are just literally just a waste of performance. All right, anyway. Back to this. So, this is going to take forever. I just realized. I don't know if it's worth it. You know what? Let's do this instead. We have like 12, right? What's 12 times 32? 384. No. Minus 10, eh? Oops. I wonder why. Okay, let's set these all to be minus 10. What? Oh, it's because I moved everything. Yeah, that's right. Alright, so let's just move this up. Let's extend it. All right. What else? This is unfortunately going to take a year to do. But I hope it'll be worth it. Keep moving it down. So we got mask 2, let's just do all these. Oh, I should not have done any of that. So this is 2. This is 3. We got 4 here. And 5. And 6. 7. 8. 9. 10. 4. 5. 6. 7. 8. 9. 10. 11 and 12. Okay, so now that we've got everything, what's this? Oh, right. No, it's fine. Let's just hide all this stuff. Okay, so 2. We also move this to the bottom. Lock it. Okay. So 2 will go up here. 3. Be here. So the first one has to be the same because I'm going to have to assemble this in code. Oh, goodness me. I better be happy with these sprites. I just realized because they're not changing, obviously. Where's 9? Where did that even go? Do I think that AAA games will ever move from C++ to something else like C#? No, because C# isn't native. I feel like at least for the longest, for like the unforeseeable future, I would say that games are going to continue being written in native code because the overhead of having a virtual machine on an actual, like on every single device, because obviously like if you boil down C# or Java or anything, it obviously goes to native code because that's the actual like thing that's running it. But just the overhead of having to deploy a virtual machine along with everything else is just, it's a bit weird. It's a lot of overhead, and it's just not really a thing that is needed right now. So yeah, this is actually a bit awkward, this one piece. So I feel like no. Like it'll be a while before anything like that happens. But yeah, I wouldn't rule it out. Managed languages are generally a lot faster to develop in, as well as a lot safer in terms of you know, how likely it is that you'll get crashes and bugs and stuff like that. But yeah. What's up, Donos? What do I use C# for at EA? C# was for tools. So any engine tools, such as the level editor, for example, that's written in C#. And like every other tool, of which there are like 20. All right, there we go, done. Yeah, it's easy to whip up, and also if you're doing, if you're working with Windows applications, which you are, because we use Windows, and everyone who makes our games uses Windows. So using something like WinForms or WPF to create actual like graphical tools, like tools with a user interface, it's obviously very easy and very nice, because Windows like obviously has probably the best like GUI kind of API and support out of any operating system. Some people say it's debatable, but I Windows is a clear winner, I think. All right, let's export it with alpha. Did I? Yeah, no, this isn't. Yeah. No Linux love. Yeah, I just don't like Linux. I mean, I use OS 10. I use Mac, kind of. Although I don't use it for development. But I do use it, but you know, like Linux, I just don't need for it. Like no one in the AAA space uses Linux. Like obviously for servers and whatnot, yeah. But I'm talking about for actual developing the actual game. No. So, I mean, to be fair, like I do use Mac quite a bit because like my desk does have an iMac on it because I need that for like iOS stuff, but it's just such a pain, just like getting all of the code for the entire game in Xcode and watching Xcode just suffer with just like even just like laggy Xcode on like a good iMac because of how much code there is, and not to mention it takes 22 minutes to do a build for Mac. 22 minutes, clean build of like one of our games is like 22 minutes on a Mac, which is ridiculous. Because on Visual Studio, it's like 4 or 5 minutes. So probably even less. In fact, for Android on Visual Studio, it's like probably about 5 to 6 minutes. And then a Windows build is like 3 minutes, 4 minutes. But yeah, so so this really is true. Compiling, because it takes 22 minutes. So, yeah. True story. All right, anyway. Let me put this somewhere. Call this, yeah, rock sprite sheet. Rock fragments sprite sheet. All right, back in here finally. Let's write a sprite sheet class. Clang isn't slow. Apple's version of Clang is slow. Because Clang is, obviously we use Clang to compile for Android as well, and that's on a Windows. That's through Visual Studio, and that takes, as I said, like 6 minutes. But for some reason, an Xcode clean build takes 22 or so minutes. So Apple's got their own little version of Clang, and I'm not sure if it's probably like the linking that's extremely slow, just because linking is extremely slow. But I'm not 100% sure. I probably should take a look at exactly why it's slow, but yeah. I only had one interview. I had a 2-hour technical interview, and that's it. My first ever job interview. True story. Because I had never had a real job before then. I mean, I had like a little job at like a medical clinic when I was like 15, but that was like through family. Well, through my family friends, I should say. And then after that, I just like YouTubed. So, yeah. All right. Sprite sheet. Okay, so string path and we should just take in a texture, shouldn't we? Yep. Texture int x count, y count. That'll be enough, right? Do I just make a new engine for everything? I don't really. This was kind of a split second decision, and this is like one file that I'm going to extract. I haven't really. The engine that I made for here is very unique because it's literally just like Bezier curves and like a few other functions. So like it wouldn't really take me any more time because I'd have to go find that code, especially because I wasn't expecting to use Java as well. So anyway, what was I doing with this? So let's get the pixels out from the texture. Let's go through the Y counts and the X counts. Okay. Let's quickly divide this. So int SW will be pixel texture.getWidth divided by X count height. What kind of questions was I asked in the interview? Oh, just like a lot of kind of performance-based questions. So like stuff like what are the performance implications of virtual functions in C++? Like as in pretty much like what do they compile to? How do they work? Lighting equations in shaders. So like normal base lighting equations, how you do that, explain verbally. Stuff like, one of the questions that I really liked, which my boss asked me during the interview, which I had to like think about and I hadn't previously even considered this, is if you have, it's actually just one of my favorite questions really, because it's a very clever one. If you have, and it also tests your knowledge of like shaders and stuff. If you, let's just say you're drawing like a teapot, and beneath the teapot is this massive ground plane, and you're doing your lighting calculations in the vertex shader. So the teapot seems to be completely normally lit, like as in the teapot is being lit and everything looks good. However, the ground is completely black. Why? And I'll give you guys a second to guess the answer to that before I tell you what it is. But it took me like I think like 20 seconds really to think about it. It's a good question. So I'll see if any of you guys know the answer. It's not a terribly difficult question, but it's one that makes you kind of think. And while you guys think, I will do this. All right, I will explain the question one more time for those of you who weren't listening. Essentially, you have a teapot, and you're rendering a teapot, and the teapot looks like you're basically doing lighting, right? And you've got your scene looks like you've got a teapot and you've got this plane, like this ground plane, right? It's pretty big, and so when you're looking at your game, the teapot looks like it's being lit properly. However, the ground plane is just completely black and just not getting lit. And then all of the lighting stuff that you're doing, kind of like you're figuring out light intensity and whatnot, you're doing that in vertex shader. So why is the ground plane black? Why is it black, but the teapot seems to be lit perfectly? It's a pretty easy question, actually. Like, as in, it might take you like 10 to 20 seconds to think of the answer, but it's a really nice question. And the light source just for this is probably, it's just a point light. It's above the ground plane. So it's not. Yeah, so a few of you guys have figured out the answer, which is good. It's because of the lack of vertices that are on the ground plane, right? Because if you tessellate it more, then there will be vertices closer to the teapot. And if your light is kind of close to the teapot, for example, which would be the case if the teapot is getting lit and if it's a point light, then the ground plane simply must not have enough vertices, because obviously when you're doing lighting in the vertex shader, you figure out the distance between a vertex and light source. And if you only have vertices on the corners, then that's a very long way to the vertex from the light, and thus you'll get black when it interpolates it. So yeah, you could do fragment lighting, but that's, you know, not the question. So yeah, good work. But it's a very good question, and obviously everyone should be able to answer that. All right. Anyway, enough interviewing. So congratulations to Pukin and Tom1024. You got the job. All right. Cool. But performance implications of virtual functions. That's your second question. I mean, I guess you guys do have the internet. But yeah. I did enjoy my birthday. Thank you. Thank you, Different Guy 3. What keeps buzzing me? Right. So much stuff. Something vtables. Yeah, so it's generally just a question of understanding how virtual functions are actually implemented. And yeah. Yeah, of course I've touched engines other than my own. Like, the engine that I work at work is not my own. As in, I didn't write it myself. Yeah, so essentially it's just a vtable lookup. So you need to, so it'll have like an object ID that it looks up in the vtable, and the vtable will have a function pointer to the actual function that it needs to call, and it can't know that until runtime. So it has to do that, like, it actually has to jump to the vtable, look at the thing, get the value back, and then jump to the right function. So yeah, it's not that expensive though. It's like, I don't know, maybe like 5 cycles, probably a bit more. I'm not sure. I haven't actually, there's never been a time where I have been like, oh, let's find out why this vtable lookup is so slow or anything like that. So it's fine. Yeah, but the vtable is like baked into the binary, into the executable. It's there. It just doesn't know what the function will be. Like, it just doesn't know which function to call when it comes up to the point of calling the function. So before it calls the right function, it has to jump into the vtable, take a look at which one it actually has to call, and then call it. So yeah. All right, anyway. Yes. What did you say? What was the question? I didn't actually understand the question. How am I so calm? Well, it's not that difficult to make a game in 48 hours. Like a small game. Okay, so y offset would be y count times width plus y, rather, x count sprite width plus x. So lol. All right, let's actually do some work. So textures index plus plus equals new texture sp sw sh. I just can't be bothered typing out a for loop. What was that? Source. How did I just do that? Very annoying. best. So public texture get textures, return textures, and then I guess we'll also be like because I'm lazy. All right. So let's load a sprite sheet. Do this in a wall. No, actually I can do it here, yeah. So new texture would be new texture. Rock fragments sprite. What did I call it? Something like that? Yep. I was right. So I think we got 3 by 12, right? It's a lot of sprites. So let's just see what we got here, really. Let's put a breakpoint. Oh, of course we crashed. Of course I couldn't do anything right. So XO, what, 96? That's way too much already. XO, X count. Oh no, XC. Wait a minute. Yeah, this should be YC. Okay, good. So loaded it. So sheet, textures. So we do indeed have 36 textures, which is correct. They're all 32 by 32, and they're probably all correct. Now the nightmare is about to begin, because oh lol. All right. So animated sprite. What do we need for this? Public animated sprite textures. Okay. Click void update. Counter. Okay. So, done. Yeah, it's done. So, level. Broken wall. So we should really just get that here. Okay. Control Shift T is the shortcut to open up the open type thing. Although with this stream delay, I bet people will probably reply before I do. Anyway. So walls are a bit of a special case for now. They're not even walls, really. They're kind of boulders, but you know, whatever. I do play instruments. I play piano and guitar. I also sing. It's pretty exciting. Okay, so that's good. Now we can So, broken wall. This will just be sheet dot get textures at length. And we will lol. So, how are we going to do this? Annoyingly, here's the answer. Oh. So we know that like every single oh, this is awful. Okay, I don't even care though. It's fine. So we know that, yep. So we'll just do something like x equals 0, x is less than 3, x plus texture x equals mini sprites, or rather sheet dot get textures x, but it will be plus a. This is the sun, by the way. The light that I'm using is natural light because, as you can see, it's 1:56 p.m. Okay, so we've done this. This is good. Now we'll just... Okay, so what does this have? It's got a bunch of textures. We still need the offset though. So how are we going to figure that out? It's just going to be plus I, it looks like. So this is wrong. It's going to be that. This is very hard-coded, but it's okay. This should be called textures. Okay. Time zones are latitude, not longitude. So, the southern hemisphere has differing time zones based on the latitude at which you're located, not longitude. So, I think you might have the wrong idea, pal. Or you're just joking, in which case, it's hilarious. Yeah, I don't know. Maybe I should be upside down. Maybe I am. Maybe I've just set the... maybe I've just set my broadcaster thing to flip the camera. And I'm actually just scaling it by negative 100% on the y-axis. Yeah, am I doing that? You'll never know. Alright, anyway. And besides, everyone knows the Earth is flat, so it's okay. Okay, so anyway, is this the best thing that you've ever seen? I think it is. So that'll happen once at the first broken wall that gets created, and then after that it's fine. Control Alt down arrow. What is that even used for? Seriously. Alright, anyway. Up and down arrow seem to do the same thing. Oh, they just duplicate things. I see. Exciting. Alt F4, I wonder what that does. Lol. Okay, so we need to make this work now. So, animated sprites. Yeah, GM Skittles is now banned because I he's just annoying, really. Use Linux. Solid advice. Not. Ha. No, don't worry, I saw you. Okay. So the positions are gonna matter, unfortunately. Do not feel wrecked. Draw texture. Yeah. Hmm. Hmm. Okay. I don't know what this is gonna look like. Well, I do, but we'll see in a minute. So level. Let's stop the camera movement. Add new broken wall at 50 minus 1500 or something like that. Maybe like 250. See if this even runs without crashing. Null pointer. What's null? One of these, eh? Huh, right. I see. This should not be I. It should be I divided by 3. Maybe. Why are there so many? How many animated sprites should there be? There should be 12, right? So, how many are there, first of all? They seem like they're way too much. No, there were 12. I only did like 4. What? Why? Oh, I see. Okay. No, this is supposed to be I. That's not supposed to be positive 3, though. Alright. It's all good. This is all correct. It's just that this should be I times 3. I believe. Yep. So what we get now. Alright, good. Let's position it better. Where is it? Maybe it's just not rendering. Oh, well, it's not rendering. Lols. There we go. Well, that looks weird. Alright, good. This is exactly what I wanted. Now I can flesh it out. So, this logic is going to be pretty interesting. Because first of all, what do you space them out? So, explosion's probably going to go like this. So they're going to have a few vectors which essentially will drop closer to be 0. So basically, First step, let's not update this. We need to set these back to 0, so I'll just relaunch it. Alright, so we need a bunch of initial values. So here's what we're going to do. We're going to reconstruct it now. Like roughly. It can be one frame off, which is kind of the point. So let's begin with the first piece, which you guys can't see, but I can. First piece of this is in the bottom left. So the first thing I'll do is a few things. First of all, x is going to be plus offsets I dot x. It's probably gonna float us. We don't really need to be doing this casting, it's just because I can't be bothered making a vec2 class that takes in integers. Because lol. So let's just, for now, like, can I just do a find replace on just that? Is that gonna work? Because I'd like to replace 1, 1 with like 50, 50 or something. Or like even more. Did that? Yeah. Okay, cool. This is just so that it doesn't run or anything. Okay, so now let's play with the offsets. So we'll bring this piece to 0, 0. And it looks like it needs to be about, like, well, I guess we'll see, but piece number 2, we'll also bring in. Okay, so let's assume this is something like -5, or rather this one's probably -5. Maybe even more, because it's 64 by 64, isn't it? Negative, like 15, positive 8 or something. Okay, then this one has to be like -20. You know what? It might really help if I scale everything up, so I can actually see. So like 4. And then we will move the camera. So 0. Let's move it to like 100 and like 200 or something. Where are we? Okay. Where was this thing? There. So that's probably too much, right? Yeah, it's way too much. Oh, it's taking a lot of time. 200-ish. I guess it should be negative, shouldn't it? Oh. Oh, there it is. So we need to really center that. So let's say 300, but that seems to be making it worse. 0. Yeah, so that's back to square one now. So if we zoom in, it'll zoom there. So we should just increase X, it seems. That's what I tried doing. Okay, so it's not a lot across X, but 200 is the middle. So let's just try reducing this then. Okay, there we go. $700. So if we zoom in a bit more. All right, that's good enough. Yay. Yeah, I think someone told me I look a bit like Chris Pratt before. I mean, I don't really see it, but sure. Whatever floats your boat. I mean, I guess I do a little bit from this angle, actually, looking at the camera. Anyway. So, broken wall. Yeah, so that's that part. So if this is -8, this really should be like 15, I think. Because we have to kind of pick a relative point and then we have to kind of work from there, so. That's pretty good, a bit more. Not that much. Okay, I'm pretty happy with that. That's just about how it looks in After Effects. Alright, now that piece just seems to be like right there. Yep. Number 3. Alright. Bit more across. Yeah, that's good. And then up a bit. That's down. That's more down. That's pretty good. Number 4. So in case you don't know what I'm doing, I'm recreating it from this, right? It's like putting a puzzle back together, yay! So, 20... That's also 4, right? Yeah, so that's just supposed to be way across. What? Excuse me. Piece number 5 just needs to get lowered a bit. number 6. Oh, why did I do it this way? So many small pieces. Looks like I got the middle pretty well though. There was that piece of negative 26. This is like positive 26. Nice. Nice. That's pretty good. This is like a game in itself. Putting puzzles back together, fun. Okay, so like 15 and maybe 22. No, 23 and 14. Much better. Okay, number 8. Which one is that? Is that... Oh, I think I know which one that is. Yeah. Number 8 is actually the one that's kind of near number 2. So we'll just go like negative 0-ish. Okay. So this gets pulled back a lot. Not that much. Oops. Okay. Okay. Almost done. Thanks to Java's live debugging, this is actually pretty easy compared to what it would have been in C++. Although in C++, to be fair, I would be probably using some kind of tool to do this. In an engine and whatnot. Ideally, I'd be using Sparky for this, but still, like, it would require a lot of modding right now to get Sparky to work with my idea. This just kind of sits here like this, I think. And then number 10 is this one. It's just a lot lower. I meant that. More across as well. It's pretty good. And final piece of the puzzle. Okay, so I think we're gonna have to go with like 18, and maybe I'll pull that one up a bit. Okay, there we go. That looks pretty good. So if we take this back to scale 1, yeah, looks good. All right, so can't go much closer, unfortunately. I think we need to. All right, animation wise now. So basically, when a broken wall gets created, okay, let's get this quickly and pop it here. That was the whole point. Okay. So when we start, we'll probably say that Unfortunately, I'm probably going to have a vector for each of these. Unless, because I could just blow it out. But I kind of do want to have like a little curve. We should simulate gravity as well. So we'll do all this stuff in floats. So gravity is probably going to be like 9.8 F or something. We'll probably increase it a lot and whatnot. We'll have a velocity. Might randomize the velocity as well. But for now, we'll just do this. Like 10 or something. And we're definitely going to have to zoom out here. So, yes, we also need positions for everything. All right. So that should give us the same. Good. And now let's just say that in update. Oh, actually, let's just see what this looks like. Whoa. Fun times. Okay, let's just say that. I'm not sure if I can actually simulate this in a for loop, because they are randomly distributed as well. And I kind of do want them to go roughly the same. So, unfortunately, yeah. Yeah, I mean... Because they can't be random, like the pieces have to go in the right way. So it is very annoying. Yeah. Let's see, let's figure out a good way to do this. So, like, we need to... So we'll have a bunch of deltas. yeah, I'll just set them up for now. And then when we actually explode, I will set this to, so we'll set it up, one sec. I'm back. Sorry. Went and got some food. No dingoes. So for this animation, I mean, I could eat off stream, but let's be real. Shono eats, yeah. Who wouldn't watch that, exactly? Alright. So just because I want to play the animation over and over again for a while, I'm going to do this. I'm going to just pre-generate the animation, obviously, beforehand, and keep playing it over and over again so that we can see it work. And then maybe I can make a GIF of it. I could, but yeah. So, best. Okay. Oh, I just watched the GIF. It's pretty funny. I'm eating like a little, don't know what you call this. I don't know what you call this, so I'm just not gonna say what I'm eating. Deal with it. Hmm. 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 Baby, that's the word. Oh, thanks, guys. No, I'm just kidding. It's like a little pastry with like potato inside. This is what's left of it. Unfortunately, one more bite. And then, you know, it's gone. No more eating. My grandmother made these. Fantastic. Yeah, pioshki would be the word in Russian. How would you translate that to English, I wonder? I'm just blanking on the word. Anyway. Ah, lols. So this will be interesting. Oh, are you kidding me? Oh, whoops, what? I completely missed the actual thing that makes everything work, which is pieces I dot position dot add. Very different ads though. Okay, good. bloody stopped there. Oh yeah, obviously. No, stop lolling me. Oh yeah. Bit too fast. That's pretty good. Okay. Now we can tweak this live. Simply by doing this. Oh, except you, yeah. Can't do that in Java. Because why would references be important? Okay, good. If I was to change this to something like that would change maybe? Maybe not. Wait, position.add. All right, yeah. So is that working? I mean, it should be, but it doesn't look like it. That's weird. That doesn't make any sense. What have I done? Like if I set that here, will that work? Yeah, it does. So why? What? Oh, I see why maybe. No. Ah, I should just do this instead, really. Okay. That's not the delta though, is it? That's the actual position. It kind of is a delta though. Let's see what happens if we try and add... Actually, we don't even support that. A value. Oh no, we don't need that. My bad. So let's see if we add the gravity. Something a bit more dramatic. Sure. This is supposed to be adding at each frame though. Doesn't look like it is. So we take the last position. That's very weird. Oh, we haven't even done the spinning yet. Look at it spinning. Yay. Nah, it looks real, right? That's just so weird. Why is that behaving that way? It doesn't make any sense. Well, it does, obviously, but why? So we keep adding... No, maybe we should do this instead. Nah, that'd be weird. Yeah, we could just do like a int grav, or in fact something like position.add 0i times 3 or something. Result equals it still doesn't. Oh, whoops, should be a times 5. Yeah, there we go. Now we got some gravity going on. It actually looks quite nice. The piece spread is very far though. I might reduce that a bit. So it's 0.8 right now. That's more. Let's make it like 0.2. No, that's not enough. So right now it goes for 12 frames. We can fix that though. We give 24 frames. Better do that change first. There we go. That was quite nice, I think. The spinning's really low frame rate. Yeah, I know. Let's fix that. Actually, I didn't even have to close that. Let's just set the animate sprites I dot set rate to more is slower, right? Yeah. I feel like that's pretty good. What was the default one? It was 6, yeah. I think 3 is too fast. Yeah, I think I quite like 6 actually. All right, cool. So this needs to be moved over here. Oops. Oh yeah, randomness. We should probably add randomness, shouldn't we? Okay, we could do like a there's one thing we could do. Well, that just ruined everything. Let's not do that. I'm actually quite confused as to why that ruined absolutely everything. Let's maybe do a next int 2 plus 3 or something. What? Oh yeah. Nah, I'm not gonna bother that. Randomness would be nice, but because of the way I've set it up, it actually is a bit difficult to do that. I don't think we need it, maybe. Okay, so let's actually make it work properly now. Destroy wall. Okay, let's just restore order, I guess. It's not completely restored. Oh, crash. Exciting. What? Oh, whoops. Oh, let's restart it. Should probably get the animation to not keep playing. Looks pretty cool though. Okay, let's get the animation to not keep playing. Exciting. Exciting stuff. Alright. Enough playing it. Alright, well, ship it, I guess. Done. The objective is to, I think it's up to you, as in like, yeah. So if you hit the blocks with the tip of the plant, you die. But if you hit the if you hit it with like your root, it's fine. You'll destroy them. So I need to make some game over stuff, and we're like done. Kind of short game this time. So in fact, it's in here. So I guess if I is, so we can say I equals 0. Let's just set the color to like black. Yeah, because 0 might actually be the root. So segment count. Yeah. So if I we'll do like -3 or something. Move. Oh, that's difficult. Okay, so we're gonna destroy some, it's fine. Then if we collide it with the head, GG. Okay, cool. So we're gonna just make this like quit the game or something. Whoa. Where am I? Here. Yep. Alright, done. We should probably try and improve the graphics though. So I should probably just draw some clouds or something, right? As the background. Let's maybe pick a better color. First of all, because I'm getting sick of this one. All we need is like Adobe Couleur or something. That's almost what I've got actually. So in terms of colors, we could do something like so let's take these color values. I'm just mixing up some colors here. Let's make the curve thing that color. And let's make the sky that color. And let's make these things. That color. Maybe we should switch those two actually. Where am I? Yeah. We could go with instead of sky, we could go with kind of a monochromatic theme. That could be quite cool. Like, because I quite like that, for example. That might be better. So if we make this thing, I don't even know. Okay, those things we can make quite dark, I think. So like, actually, making that color, and the curve becomes either that, just a bit too dark, I think, or in that case, that. Yeah, that's a good color for the curve. Then we can make the background, I think, this kind of dull color, which just looks really nice. Yeah, I've got a very green kind of scheme. It's either that or 7F2A. Yeah, I don't like that as much. No. Okay, so then these things are just annoying me a little bit. Where are they? What if I make them 7F2A? Oof. Draw the curve last. Nah. So 267 F44. Was that color? So do we want to go for like a darker one maybe? Or reduce everything? So we could just do that, right? Or maybe even darker. That kind of looks nice. And obviously I could place flowers and whatnot in random places. And maybe we could do like a cone of light or something at the top. And we could easily do that. Yeah, let's make like a light source. I think that will make it look better. I don't know how much room we have for lighting. It's 400 frames per second. Should be enough. Let's do some lighting. Well, I'm probably not going to be able to afford more than one light. We'll have an ambient light as well. A fake ambient light. Okay, so this is going to be pretty simple fragment-based lighting, or pixel-based lighting, I should say, where we just simply figure out the distance between the pixel and the thing. So we don't really need to square root it. That might be a bit too expensive. And we don't really need to square root it as well. We just divide it by something. So that might be a better idea, but I don't know. We'll see exactly how this works. So float distance equals get distance I was going to say something about deferred rendering, but we don't need to think about that. Okay, so get distance between x, y, and light.x. Light.y gives us our attenuation. Let's still call it distance though. And of course intensity is going to be used for multiplying that, and for a smooth gradient one, we probably want to not have it exponential, so I mean this is obviously going to be multiplied by like 0.01 or something ridiculously low. So we probably don't even need that, and then I'll just do pixels x plus y times width times equals attenuation. Okay, so this should be like black or not. We're doing our light bars? Oh no, we're not, because we don't have any lights. Okay, so let's add a light. Whoops. $250, $450. Well, I screwed up some maths. How is that possible? I mean, I guess I just went over 255, right? Oh, whoops. I thought it was like a vec4 or something, my bad. So this is going to be... Yeah, I know, fun, isn't it? Okay, good. Except it looks like I may have done it the other way around. Okay, sure. 50. Yeah, I need to definitely extend it a little bit. The fall off is very annoying. I mean, look, an easy way to fix this would be just to move the light up, and I think that actually just might be the best solution right now. So basically, if I just set the light Y to be like negative 50 or something, or more like 500, then we kind of get exactly the lighting that we wanted. Yeah, where it's kind of just like that. It's kind of a gradient light, right? Oh yeah, look at the frame drop. Great. Yeah, I knew that would come. Yeah. I don't know, man. We can optimize this obviously a lot, but too much. Yes, so one way we can optimize this is by getting rid of that square root. Now, obviously that's going to ruin everything for now. Because the distance now is way too big, but we can simply multiply it by like 0.01 or something. So let's get rid of that. We actually might need the square root, because I just realized that we're not, yeah, we will need the square root, unfortunately. No way around that. Although that did speed it up, right? Or was it just not even significant? Yeah, not even worth it. Not even worth getting rid of the square root. It takes up like 15 frames. Okay, so what can we do here to speed this up? So how much does the light pass take up? That's for one light as well. Okay, so it takes up like 2/3 of our frame rate. Nah, square root's not even worth optimizing at this point. Okay. So, part of the problem is all this junk. These branches probably aren't helping. No. It's just writing to all these pixels that's taking all the time. It's not even our calculation, it's just the fact that we have to do it for every friggin' pixel. Yeah, I could just create a light map. Look, there's actually just a really easy way to, I mean, because this doesn't actually have to be done dynamic, so I could just create a texture, which is essentially a light map. And that wouldn't be the worst idea. And you can see the speculas on the things as well. That's pretty cool. Pretty simple too. This is where the graphics card would come in handy with its parallel processing abilities. What if I multi-thread this? I don't think it would be faster, actually. Just because it's not set up like that. It wouldn't introduce any race conditions because I would wait for the frame to finish before I did another frame. So it wouldn't cause any problems. It's just that dispatching the threads. I mean, it's just such an insignificant amount of work that dispatching threads for this would be way too much overhead. But yeah, because I would obviously have to wait for the threads to join anyway before I display the final frame. So it's fine. It's not, it would work, but it's just going to be very slow, I think. So yeah. If we had multiple lights, I could probably figure out some optimization stuff, but for a single light, why is it so slow? Is it because I'm streaming? Maybe. I just wonder if I actually point to this. I know light map would be easiest, but it's actually not that easy because anyway, I was going to say the reason it's not so easy is because currently this has no blending and no alpha support at all. But the reason I don't think light maps are going to be faster is because we're not actually doing anything. Like the thing that is slow right now is writing to like all of these pixels. It's not like a light map. If I had a light map, it would probably be the same performance, to be honest. Probably exactly the same performance. Because if you look at it, it's not actually the lighting calculation, which is like all this stuff that's actually slow. Like if I were to just set this to like, I don't know, white or not, Okay, let's just set it to like 255. This is blue. It would still be extremely slow, as you can see, because it's not the actual lighting calculation that's slow. It's just all these pixels that are slow, right? Because we're doing it per pixel in a software renderer, which has no concept of parallelization. System out of print line does not take any performance when it's happening once per second. If I had it in this loop, yes, this would run extremely slowly. Or like not at all. Look at that. Awful. There's only one light, so this might as well not even be here. I'm not sure that there's actually much we can do. Yeah, I don't think the array list is a problem. I mean, I could try to do this. But it's 20 frames per second faster. I'm actually really surprised the Java VM didn't do anything. So it's like 90-ish. It's like got us like 10 frames. We need some more optimization up in this bitch. I just don't think that we can do much without parallel processing. Dawn Oz, welcome back. All right. Okay, yeah. I can't do much to optimize this, at least not in Java. Let's send it out to native code. That'll make it faster, right? No. Yeah, I don't know, man. I'm just gonna have to man up and just have a good computer to play this incredibly graphically complex game with no hardware acceleration. Hmm. Yeah, it's just, there's a problem because there's like a million pixels we have to write to. Actually, I mean, I do have to clear the screen. Otherwise that will happen. It looks really cool with this thing. That didn't even speed us up though, that's what's weird. Look at that, how cool is that? Yeah, who says we have to clear the screen? This looks awesome. Oh, whoa. This actually looks insanely cool. Look at that. Holy crap. I may just keep it like this. This is amazing. I did not expect this at all. Look at this. It's got like motion blur and everything for free. I actually just don't understand why this is happening though. This is so cool though. Man, this is insane. This actually brings FPS back as well. Goodness me, that looks cool. Look at that massive white light as well. Wow. Alright, I'm not actually gonna keep it like that. It's barely better FPS as well. And this is like, this is along with the CPU cache. If we reversed this, it would be so slow. Or maybe not. How is that faster? That makes no sense, Java. What? Does Java not store memory? What? Okay, apparently this is faster. Or not. Make up your mind. 127 FPS. What? Is this a coincidence? How is this faster? Does Java interleave arrays? That doesn't make any sense. No, it's just very weird. It should be the other way around, because now I'm not reading memory in order. Or writing to memory in order. That makes no sense. What? This should be a lot faster than the other thing. Oh, now it's like the same speed. It's very weird. Java's very weird. I guess it depends how many things are rendering on the screen as well. Although that one did seem to be faster. The FPS right now is expected to probably get lower the more you play, because I'm not doing any culling. In fact, that's a good idea. Let's do like a bit of a... Let's do a bit of clipping, culling, whatever you call it. I'd probably call it clipping because it's 2D. It's not really like frustum culling or anything. It's also a lot easier and not as expensive. We could write a faster renderer. Can I be bothered though? I don't know, I'm just so lazy this Ludum Dare. I don't know why. I just cannot be bothered doing any of this. Oh. It's like 4 p.m. It's not late. Yeah, I do usually listen to music, but like, you know. Fresh cup of motivation. A fresh cup of tea would be nice. Maybe I should do that. So a few ways we could fix this. We could rewrite the renderer and make it actually good, like a good renderer. We could port this to OpenGL. Which, there's no way I'm doing that, by the way. That would be... We could port this to Sparky. I bet this would run so quickly in Sparky. Is it bad that I'm actually entertaining that idea? It would be difficult to convert it into LWJGL because I don't have to write a renderer. Oh man. All good options, but all would take so much time to do. The texture is not going to help at all because writing pixels is slow. It's not the actual thing. I'm not going to change again. Alright, anyway. How do you even profile in Java? Like, is there a profiler in Eclipse? Does anyone know? Can I actually just profile? Can I just get a proper CPU profile of everything right now? Please help me, someone. I don't actually know if that's even possible. Because it doesn't look like it's a thing. Add-ons. Why does Eclipse not have one? No, here we go, profiling tool. Nothing. Why? If I was using C# or something, I would use Visual Studio's profiling tools. Oh, this is the last time I'm using Java for anything. It's just annoying. So maybe I should just install new software. Profile, that's location. Marketplace. Profile. The JVM monitor. Is that a good one? Sure, why not? What did I just download? Java monitor, is that it? Can I just run this? Oh, here we go. Monitoring's not started. How do I start it? What? Start monitoring. Good. This is good. This is what I want. Give me graphs. Heap memory. Whoa. What? Holy shit. It's a lot of garbage collection. Why am I allocating that much? What? Really? Loaded class count. 2,000 something. Wow. Alright, now let's actually see the CPU stuff. Oh. Select what? Profiled Java packages. Add. Yes. Okay. Go. What? Are you lolling me? I don't care about memory. Runtime. Boring. Please show me the CPU. What are you doing? What is wrong with you? What is this for reals? Yo. Is this profiling now? Or do I have to start it again? Start monitoring. Go. Do something. This is... Hang on, what's this? Resume CPU profiling. Oh, thank you. This is what I want to see. Screen light plus 75% of CPU time. Of course. Well, we knew that much. Why though? What is it? What is in there? Hotspots. This is not as good as Visual Studio. Wow, though. That's ridiculous. Self-time 72%. Yeah. The rectangle objects are fine. They don't take up any performance. Relax. It's clearly the light pass. Draw curve takes up 2%. That's a lot quicker than I thought it would be, to be honest. Wall collision takes up quite a bit. That's surprising. Probably because... Yeah, just because it's doing it for every single... It's doing that 750 times wall times per second. Now, it's not the calls to get distance because they would show up. It says self time is 73%. So, it's definitely not get distance. Get distance takes up like no time. As expected. It's just the writing stuff that takes time. This. If I got rid of this, let's see if it would be much faster. See? If I run it now, then you would see that light pass now takes up 1% of the time. This does not add up. I just realized. Self time 2% plus 3%, 30%. What? Yeah, light pass is just not doing shit. How about now? Here we go. Look at that. Look at how it's fighting back all of that time. My goodness. Okay, so we now know that Java is slow. Other functions write about as much when they iterate over the arrow pixels, don't they? No, not really. I mean, the only one that writes this much is clear. But, like, the other thing that we're doing is we're doing a read and a write. I mean... The thing is, though, we are reading to exactly the same address that we're writing to. So... Yeah. So that's why this is like a free read, almost. Well, it's kind of not free, but anyway. And it's also happening in line. It's happening like along the cache line. I'm not really 100% sure why this is so slow. It should not be worth 400 frames per second. That is absolutely for sure. I don't know why this is so slow. I actually just do not know. No clue. I just don't know enough about Java to actually probably say why this is slow. Other than the fact that it is. So it's weird. Let's get rid of that as well. That's kind of a waste. Assuming that it actually didn't optimize it out, which would be weird. The bit operations aren't anything either. It's the writing and reading. Well, writing in this case. Okay, I don't care. I'm just gonna ship it with high system requirements. Because again, ideally, ideally this would be rewritten in like you know an actual with hardware acceleration, but I decided to do Java for some reason. Still don't 100% know why. I mean, to be honest though, it does make sense for like Java did make sense for the beginning of this because of the initial stuff with the Bezier and the fact that I was drawing individual pixels. Like that would be pretty much ridiculous to do in OpenGL. I mean, you could do it. You could either draw points or you could draw or the better option would be just draw like 1 pixel large quads. But the thing is, we blew them up. We changed this to actually use rectangles anyway, and quite large rectangles as well. Like the thicknesses here are like 10 pixels or something. So yeah, this could definitely be rewritten in OpenGL and batched together and then sent to the GPU, and it would be probably like 5,000 frames per second. I'm not even kidding, by the way, with flighting. So yeah. Oh well. Too late. Too late. Maybe I'll remake this for fun in Sparky later on. Change the function that prints the FPS to always say 500 and be happy. Yep. OpenGL 1.1 would not make this any faster, pretty much. Like, as in, it probably would, but it would still... It's actually... OpenGL 1.1 would be really, really slow with this because of the lack of batching. I know there is still 44 hours of, like, not 44 hours, like 24 hours of whatever amount of time, but I'm actually just going to wrap this up in, like, 5 hours at the latest. So, yeah. The reason I didn't use Sparky is because maybe I'll just remake this in Sparky as, like, a little side project. Or I'll stream it, or I'll do something with it. But the reason I didn't use Sparky is because it's broken right now. I think. Yeah, it is broken, because I'm doing, like, 3D stuff in Sparky now, so it's all very weird. In fact, is this? I think this is where we're at in Sparky. Yeah, so there are a few 3D things. There are a few 3D things now in the engine, and these are just these buttons just set up uniforms and whatnot. So that's yeah. Why am I not using dark? Okay, that's just not true, by the way. What happened to my FPS? Anyway, maybe this whole thing is slow because I'm streaming. Maybe that's the reason. Because this as well just does not make any sense. I was just going to see if I could set the VSync to be false. See what the actual FPS was. In fact, maybe the FPS is sad because I'm streaming. Okay, that clearly just didn't work. Oh, I know why. This is not actually a thing anymore, is it? Not implemented. Yeah, I removed that because I changed stuff. Anyway, it's all just all over the place, so I can't use that. Well, I could use that, but like it's just not gonna happen though. It's too late. So lol, low performance it is. All right, let's finish the game. Let's make it so that we don't even have a player class. This game is so lazily written, but I just don't even care. Where's our curve? Try and draw curve. I like how I'm doing all my logic and collision detection inside the screen class. Yeah, pretty pro, isn't it? I just don't care anymore, really. Soz. I should probably figure out what this actually is, though. Because let's quickly just figure out. How can we do this? We could just. What was I saying? What are the specs of my computer? Intel i7 3770K, like 16 gigs of RAM, GTX 680. Yeah, that's about it. And like 5 hard drives, 2 SSDs. So, what was I doing, bros? What was I doing? Like, I was making this game, but what specifically was I doing? Oh yeah. Where's the mouse stuff at? So if it's less than like, yeah, we'll go 50 or greater than 480. Okay, so game over. What are we going to do for that? We're going to render some strings. Now, how do we render strings in a pixel renderer? Well, we don't. We cheat, because cheating is fun. So, we also write horrendous code, because that's also fun. So, public static. Oh, man. List, string buffer equals new array list. String string thing. Public vector 2f position. Public string public string thing. string vector 2f position. This dot string equals string. This dot position equals position. All right, string thing. Equals 0 is less than string buffer dot size g dot draw string facts. Okay, done. Pretty exciting stuff. Totally good. Now, let's see where we are in level. ASD over, yeah. I could do that. I could cheat, yeah. Yeah, I could do that. That's a good idea. Monkey Ninja. Maybe I'll do something like that. Ooh, maybe I'll use these characters. Maybe not. Okay, so what we'll do is we'll say that. So we'll have a score as well. We'll have to make it get harder as well. Oh man, the music for this is going to be so lol-tastic because I'm just not even going to bother much. I don't know, man. This Ludum Dare is just like, it's December, it's not a month for working. So, I don't know. Dunno, bros. It's pretty lazy. That's all. That's all. December is exam time. What? Maybe if you're like in some northern hemisphere country, sure. Yeah, the source code will be on GitHub at the end. Don't you worry. It's disgusting though. I don't even know if I want to publish this under my name. I need to implement this, so yeah. I don't want to make a new game. This is a good game. I just don't want to make any game right now. All right, let's do something. Yeah, if you guys want to like do an anti-aliasing post effect after the fact that doing a lighting pixel writing thing has resulted in like a 70% reduction in frame rate, then go for it. Go for it. If it was OpenGL, then yes. Possible, due to the power of graphics cards and their parallelism. True story. Move the light to the right so it's not centered. Could do that. I don't know if I actually like that though. I don't think I do. Soz. Okay, so anyway, left and right side again. Oh man, not the right file. The no clear screen thing is an Easter egg. Yeah, okay, I might do that. Alright, so let's say that if the state is 1, it's gonna be pretty simple. It's just gonna be that. It's actually a bit annoying. Whoa, look at that skill. Okay, so I probably shouldn't make it. I should probably make it so that it lets you release all the keys or something. You have to release the key first. So we could do like do this key typed thing. That's not what I meant. It's way faster. Okay, press.add key and then return true. Okay, so that's still, yeah. The reason it still does that is because, lol. We could, you know what we could do though? Just a little hack. We could run that here. What? Oh, I see. It's always going to cache it. Ah. Oh, no. No. We could do this. So hacky. So now we can play the game. It's actually pretty difficult. Oh, I died. We should probably make like a radius check here instead of the other thing. Oh. So we need score. No, you can see the other one appearing, lol. Oh, well. Oh, so it actually appears a bit too high. Maybe I should fix that. Oh, but I was going to fix the rendering first. That's fine, yeah. Cool. Okay, so now for this thing. There we go. Oh, it kept adding him. That's great. Oh, that's actually a bit of a bug, isn't it? Because if you happen to do that, it's going to keep adding them and your frame rate's going to plummet. Because that's probably still getting hit. Oh, it's not. It was that one time though, which was a bit weird. Oh well, cannot reproduce. File editors will not fix. That was weird as well. I guess you should get points for destroying these things as well, right? Why not? So difficult though. Oh, I need to do the culling thing. Oh, I didn't die there. That was nice. Oh. I think that might have been the bug thing. Also, I think that they always exist. Oh, that didn't work. Oh, of course. It's because of this. So yeah, he keeps adding that. I know that's why. Fixed. Okay. I can just do that. It's gonna be the exact same, so you know. Look at this. It's like a pretty solid press. It's very weird. Oh, this is some solid, hard stuff. 70,000, look at that. Wait, how did I get so high? Wow, it does like, give me like 20,000 score, what? How many times does that run? Oh, it's for each of those. I get it. That'll fix that. No, it's not the animation. It's because it's doing it for each of the rectangles which makes up this line. I like how it pauses when you can see the fragments. It looks very cool. It would look cooler with smaller branches off the side, but no one's got time for that. Come on. Especially not lazy Jono. Okay, I need to go and have like lunch / dinner combined into one. No, I missed that because that was kind of the bug type deal. That should not have done anything though. Yeah, it wouldn't have. Okay, so I'm guessing this should get harder. No, it went. Oh, and I gotta fix that left and right shit. Yeah, speed up would be good. Oh, no, I should have gone left. This is actually quite fun, I'm not gonna lie. Because, like, you don't really know where the thing's gonna go, so it's just all... Oh, look at that. That's awful. Also, the forces right now aren't random, they're completely predictable. It's just a bunch of sine waves. So maybe I will... Ah, damn it. Maybe I will make it better. I really should change the key from being left to right, though, just because it's... Yeah. The other thing I need to do is, when I'm updating the walls, I need to say that no, the sign optimization is not going to be necessary. Yeah, I'll probably add branches, like popping out and whatnot if I do it. My side project. We'll just make it, no. Press space to start again. The reason I'm doing this is because it's very weird to use the other one because it's the one that you use for your controlling. Okay, let's position that text better. Okay. This is a record. How long can I keep it there? Oh. Alright, I want to go have lunch. I guess I'll leave this running. Oh, that was close. Wow. Oh, come on. Really? Yeah, obviously I'm going to have to make some text. Alright. This is kind of a good screenshot. I'm off. I'll be back in like half an hour maybe. Not exactly 100% sure. I'll be back soon. Alright, goodbye. For now, I'll leave the stream running. So, later. Vroom. Alright, I'm back. So yeah, more of these would be good. And possibly faster, yeah. So yeah, so let's quickly get the how do we spawn these generate function, right? Yeah. We could do that based on the camera's Y position, I guess. So we could do something like 10,000, and we might spawn a few. I'm not sure if these values are good enough. So 1, 2, 3, and then I don't think we'll do any more than 3 because that's just going to get very hard. Ugh. Ugh. Okay, let's turn off game over. Oh, it's getting harder now. I may have lost already, I don't know. Just testing it. Well, look at all these points I'm about to get. These are pretty much impossible. Alright, I'll change it. I'll change this to be left and right. How about that? Okay, so these forces, where are they coming from? Here. So we're not going to make it that big. We're going to make it like 4, because the play can move at 5, so if we make it at 4, like, it's generally okay, I think. So we'll reduce this to be 9, which will generate a number between 0 and 8, which we can then move into -4 to 4. Camera speed is that. Let's say that if camera.y is less than -10,000, change this camera speed to be 4. So we'll have to kind of go from the top, I think. So it's 100,000. We'll change it to be like 8. 80,000. It'll be 7. 60,000. We'll do 6. 40,000. We'll do 4. 20,000. 10,000. Maybe 5, 4, and then 3. I want to do one more level though. So we'll do 10, 8, 7, 6, 5, 4, and 3 is the default. Or maybe we should start out slower. Yeah, we'll just do that. We'll start at 2. You know what song I think would suit this? I can't even hear it. That could work. Lols. if I could time the speeding up when the song speeds up. Lols. It's popcorn. Yeah. Oh, popcorn goes metal. Nah. Not the biggest fan of this one. There we go. That would be pretty awesome. Maybe I should do a cover of this song for the game. What do you guys think? Are there any other good covers? Metal cover. So many metal covers. Let me just put these on. It actually works pretty well for this though, that's the thing. Oh, there's a Muse version. So it's okay. Oh, they did live as well. I wonder what the live version of it sounds like. Well, already sounds better than the studio version. That could sound cool. Oh no, move. Oh, I should have gone through that spot, I guess. What do you guys think? What do you guys think? Just do it. Don't let your memes be memes. Yeah, no, I was watching the Muse live version of it. And I quite like it. I think it will suit the game pretty well. Oh yeah, the chorus. Just because it's like, it's kind of, it's a difficult song to describe, isn't it? It's kind of upbeat and all like, I just think it goes really well with the whole plant thing. This looked like the swinging. Maybe I could time the... Ah, that would be cool. Oh. Alright, so that's good. I could just do a cover of that or something. But I don't know. How hard could it be? Probably not too hard, right? The other thing I could do was the whole clear color, not actually clearing the screen. Because that seems to work pretty well. Oh my goodness, that looks cool. Like, look at that. That looks insanely good. Actually looks less good when these guys can come down. Oh, I know why it looks so cool. It's because of the lighting. If we got rid of the lighting, this would look like junk. Let's get rid of the lighting fast. There we go. There we go. That looks awful now. This is more what I was thinking it would look like originally. But the lighting fast really makes it. Because it does actually clear everything to black that's not black. I'm not going to make a cheat that syncs that's way too hard. Alright. So there maybe will be an Easter egg for that. Alright, well I'm probably going to go down and record the music for this game. I don't know what it will be yet. I might end up doing a cover of Popcorn. Because that doesn't seem like it would take too long. I mean, it'll probably take me a while to learn it, but... like half an hour maybe? And then I could just get that down and get it back up here and put it in and I'll be done by tonight easily. So maybe. Because I want to be down by 9 PM. I want to be done by 9 PM. I can't stream the music, unfortunately, this time. And I know that's going to upset some people, but it's because of the setup in my studio is not so great this time. It will be soon. But the computer that I used to use, I've retired it now. So I actually use my laptop. And I would have usually used my laptop to actually stream. But unfortunately, I can't both stream and use it to make the music. I usually had like an extra laptop that I set up just for the streaming. But unfortunately, until I get like an iMac or something for the studio, it's going to have to be my MacBook Pro. And unfortunately, I can't stream from that. So, because it'll be being used for like, connected up to all the audio equipment. So, unfortunately, that means that I can't stream it this time. So, that's not so great. But yeah, so I'm probably going to vanish for like 2 hours or an hour or something and record some kind of music for this. And then I will be back probably to finish this. So yeah. So I'm going to end the stream here. The progress, I've basically finished the game. Like, I need to probably have like a menu. Like, it's like, this is how you play the game. Oh. Whoa. So yeah, so you use your left and right arrow keys, and you basically try and grow this as much as possible before you... Oh man. Oh, I died. So it gets progressively harder. In fact, I might actually just get rid of the other tier thing, because it's gonna get way too hard. Yeah, string thing is the best class ever. Level. So I think 3 is probably the max then. So we'll have one at like 3,500, one at 8,000, and one at 20,000. And I think that's probably pretty good. Alright, cool. Well, that is how the cookie crumbles. I will be back. I'm going to release code when I finish the game. Yeah, that's pretty much it. Alright guys, I will see you maybe in like a couple hours.